Thank you. Well, I'd like to start this talk by thanking all the sponsors and all the helpers at DDD and all the great work they've been doing, all the assistants, all the people that give up their time to make this such an awesome conference. And it seriously wouldn't run without the volunteers, wouldn't run without the speakers, and wouldn't run without these sponsors. So this is my talk title, Full Stack RX with Reactive Extensions. And I'm going to start by explaining what I mean by that. So let's go forward. And my name is Brendan. My day job is a solution architect at SSW, which means I spend most of my time at client sites building applications, and every now and then I get out to do talks or run some training courses, that kind of thing. So I'm starting my talk by showing you a picture of a loudhailer. And this loudhailer represents one-way communication. You can't have communication person to person through a loudhailer. It doesn't really work. And web servers, since the dawn of time, have pretty much talked to the servers, not through one-way communication, but to something fairly similar. It's a very kind of asymmetrical relationship. So client-server communication, the client will send a request to the server, and then the server will send a response. And the problem here is if the server has something to say, the client won't know until it asks for it. It's a kind of speak only when spoken to kind of pattern. Well, there's some new technology out there that changes that entire relationship between the web client and the server. And that gives us something a little bit more like this. A telephone is genuine two-way communication. The two sides in that communication are equal. One side can talk to the other side, and the other side can talk to the first side. So full duplex communication. And the technologies that make this possible are WebSockets, and then on top of WebSockets, SignalR. So I'm going to run through some stuff with SignalR pretty soon. There is one impact with adopting this pattern though, and that's, this is the SignalR library, and it's a new library for ASP.NET Core that makes it very simple to add real-time bi-directional communication to your applications. But there's one thing that we've always had that's made application development quite easy, and that's the fact that with a request-response cycle, you've always got this single synchronous loop of how you communicate between your client and your server. And I'm assuming everyone heard of MVC as a pattern? So the idea of MVC applied to the web pattern always works so well because your controller is requesting from the server, your model comes from your server to your client, and you can't mess about with the model kind of in transit on the server. You have to get requested again. So MVC, the pattern, really closely follows that synchronous loop with the request-response cycle. But when you talk with SignalR, you've lost that separation of concerns. You've lost that clear pattern, that clear flow. You've got a soup of events flying left and right in any particular order. So where you used to have synchronous code, you now have asynchronous code. And you can see all these arrows flying around. It starts to look a bit messy, and as soon as things start looking messy, I start to fear that we're in risk of hitting what I call spaghetti code. So the idea here is in spaghetti code, the relations between the pieces of code are so tangled that it's nearly impossible to add or change something without unpredictably breaking something somewhere else. So pretty familiar to me. I've made a few applications in my time. No one sets out to make spaghetti code, but somewhere along the line, there's some decision makes it starts to get untidy. So really the purpose of this talk is to, okay, if we're going to be using SignalR, we're going to be using these asynchronous events, what can we do to keep that under control and stop it from turning into spaghetti? And the library for managing asynchronous events already exists, the pattern, the design, and it's called ReactiveX. So ReactiveX is an API for asynchronous programming. And the first time I used it, probably the first time many of you used this reactive stuff, is in JavaScript web applications. But it's a library, it's a pattern, we can use it in other places. So here's the contents of my talk. I'm going to start where I started with Rx and start talking about the JavaScript libraries. And the JavaScript libraries I've used are Rxjs, Redux, and NGRX. Then I'm going to move forward from there and talk, okay, these are libraries, they're great. I'm going to explain how they work, I'm going to explain the reactive programming, I'm going to explain the Redux pattern. Then I'm going to look, okay, if I am doing the same thing on the server side in C#, what are the libraries available? So I'm going to look at the C# libraries that give me reactive extensions and give me a Redux pattern. Then I'm going to run a demo. So the demo I've built is a sort of screen sharing website. So a website where two people can have the same site open and actually see changes in real time. Now I don't want you to walk away thinking, oh, reactive means screen sharing, but I thought it was a kind of fun example to show you of the kind of things you can do. And then I'm just going to walk through all that demo code and show how I've built this application using the Rx libraries. So let's start with explaining Rxjs. And I've got a lot to get through today, so I'm going to try and do the quickest explanation of Rxjs I've ever done. I also teach an Angular course, and Rxjs features quite prominently in that Angular course. But I've got a lot to get through, so let's see how quickly I can get the ideas of Rxjs from my head into your heads. So the idea of reactive programming is it's programming around this thing called an observable. So an observable is a thing that releases changes to state over time. And in this case, the piece of state I'm looking at is a single number, 1. So that's the observable, and it can emit that number, 1. If I want to watch that observable, I set up an observer. So we say the observer subscribes to that observable, and when it connects, it receives that number 1. But the key thing with observables is that arrow, that subscription, stays open. So if that thing changes in the future, and we get a new value coming in, the value 4, then that subscription will pass that value through to the observable. And so on. So that is your basic one-to-one piece of communication, a piece of state coming from an observable through to an observer. But what the Rxjs libraries also do is give you a huge number of functions, a really huge number of functions, that operate on that observable stream. They also let you operate on that observable stream, treating it like an array. So here's a function we've inserted into the stream, and it's taking that number and it's adding 1 to that value. Now the thing to also realize is, looking at these two arrows, both of those arrows are themselves observable. I can select more subscriptions to listen to that value after it came out of the map function. And so that flows through that way. And of course, I can always have more than one thing listening to any of these arrows. So I'm forking out now, and I've got 2 subscriptions listening to that one observable. And here's another function, filter. And this filter is only going to let values through if they're greater than 2. And once again, at any point, any of these arrows, I can add more subscriptions and fork out more and more pieces of state from those observables. The final function I'm going to show you right now is something called reduce. And where map and filter operations operate on one value as they come through the stream, reduce is special because it operates on multiple values. It keeps states of the previous value coming through, and in this case I'm adding those 2 values together, pushing through, and then that transforms that value like so. So I think that's the kind of simplest, most basic introduction to the idea of observables. So what you have is an observable that emits values through a subscription to an observer. And the idea is you can insert functions into the middle of that stream in order to transform or deal with it, or even combine streams together. So the next thing I'm going to show you is an example of why you would go about using Rxjs. And this is one of the most simple examples of something that's hard to do without Rxjs, but becomes much easier with Rxjs. So what we've got here is a search box. And we want to type into that search box, and after a little while, send a search to the server. But what we don't want to do is send that search through every single time we type. We want a bit of a delay. Now, doing this without Rxjs means setting up a set timeout and then keeping a reference to that set timeout. If a number comes through or new key press comes through, we need to clear that timeout, set up a new timeout. But when we're using the Rxjs, and this is an Angular example, we're watching the values coming out of that box, and that comes out as observable. We then introduce this function called Debounce Time. So it's an operation on Rxjs that lets us say, okay, we're not going to send it straight away. We're going to wait for 500 milliseconds, and if then nothing comes through in that 500 milliseconds, then we'll send our search through. We can then make sure that the values we send through are distinct. If I press a key and then hit delete again, it's not going to be distinct, so it won't send that search through. And finally, I can send that through to the server and do that thing. So here's an idea of something that's quite hard to do, or not impossible, but it's a block of code to make without Rxjs, becoming much simpler, much easier to read if I'm using Rxjs. So that pretty much covers up my introduction to Rxjs and reactive programming. Any questions right there on that? Because I've got a lot to get through and move forward. Okay, so we've already talked about spaghetti code. So spaghetti code is what happens when it gets messy. Well, in my opinion, the other thing I want to talk about is states, the management of the data in your application. And if you're dealing with asynchronous events, it's very easy for your state to turn into what's called mutable soup. So the idea of mutable soup is I've got this sea of events happening in all different directions, and all of them are changing things, and I have no idea at any time in my application what's going on, what the state of my system is going to be. So in order to avoid mutable soup, we need to add some architecture. And the Redux pattern is a way to implement a predictable state container on top of the Reactive pattern. And I'm most familiar with JavaScript, but it's a pattern that's out there. So here's my quote: "The role of software architecture is to impose artificial constraints in order to promote consistency and predictability." And from what I've seen, I know of no more consistent, predictable, and constraining library or pattern than Redux. So let's take a look at the Redux pattern. So the Redux pattern starts with this thing called a store. And the store contains some data. In this case, it's just a bit of JSON, but it could be whatever data I want to keep. And I've got a couple of companies and I've got a contact. If I want to display a piece of that store in my user interface, I select from that store using a selector. And the key thing here is that arrow is an observable. So if my state in the store changes over time, I'll be notified of those changes. I'll be able to update the UI. If I want to make a change to the thing in the store, the key feature of the Redux pattern is that piece of state is immutable. I cannot just make random changes anytime I want to that piece of store. Otherwise, I get mutable soup. So the idea is the only way I can make changes to the data in that store is to raise an action. So I raise this action, and action's got a type and a payload. In this case, I'm going to raise the delete company action, and I'm going to delete the company one. That then goes to a thing called a reducer. Now, a reducer is a pure function, which means it takes no side effects, and what it takes in is the previous state, my action, and returns the new state. So away it goes. Is that what we've basically reintroduced is this asynchronous events flying everywhere. We've introduced this synchronous loop to make sure everything happens in a kind of regulated way. I also see this as very similar to the model view controller pattern. It's the model view controller pattern, but built on top of Redux, in the fact that these arrows you're seeing are observable changes over time based on our Rxjs. So we've talked about reducers and actions and the fact that reducers are pure functions. That means they can't take in any side effects, any dependencies, any services. They can't go and send a request off to a web server to talk to my database. So what happens if I want to do that? Well, I've got this thing called an effect. So I select from my store, raise an action, and instead of my action being handled immediately by a reducer, it goes off to this thing called a side effect. And the side effect can take in services. So this is where I can send WebAPI requests or talk to my database and do some work outside of the Redux loop. But my effect can't write to the store. So what do? Well, when the effect is successful and finished, it creates a second action that then triggers the reducer. So the idea of the effect can talk to external services. Reducers are anything that change my store. So I string an effect with a success action back to the reducer, and that changes my state. Any questions on the Redux pattern before I move forward? Great, thank you. Okay, so a quick recap on Rx and Redux. Where I first encountered the Rx patterns, it was in Angular, and Rx is baked in. It's there in the library. If you change the URL, if you change a form field, if you change things in the router, then it raises events. And the Redux pattern is awesome for complicated UI apps because it really constrains the flow of data. It also introduces a bit of complexity. It introduces a lot of boilerplate code because you're now having to write actions and effects and reducers. But it means that you're dealing with that mutable soup. But I've been using this library. I've been using this library in UI components for quite some time. So my question here is, can you use these same patterns to manage those asynchronous events that come from SignalR? So let's first take a look at the C# libraries that are available to us that do pretty much the same things the JavaScript libraries we just looked at. ReactiveX is a single website that has lots of different reactive implementations. You can get it for Java, Rxjs, Ruby, even PHP. But Rx.Net is the one we're going to look at, and it's called Reactive Extensions. And really, actually, this is the first Rx library that was made. And if you'd probably be familiar with it if you're working with, say, Xamarin or something. It's very popular still for those .NET-based user interfaces. So let's take a look at Rx compared to Rxjs. Well, they're very similar in how they work. They both have the concept of an observable. And the observable is something that emits values and changes over time. You subscribe to that observable to be notified of changes. And when you're dealing with JavaScript, you've got this thing called fat arrow functions. And they give you this kind of C sort of equals arrow c.name. And that's how you kind of apply these fat arrow functions. And in C#, you've got these things called lambda expressions. And the code, even though they're fundamentally different in how they work, the code you write looks the same, and functionally it's equivalent. You can do the same things with lambda expressions as you can do in fat arrow functions. With the Rxjs library, you get a whole set of functions that operate on observable, like the maps and filters you've already seen. But in the Reactive extensions library, you actually get link extension methods on your observable. So in Reactive extensions, you get an observable, you can type .where to start filtering it, just like any other link operation. So pretty powerful stuff. So the next thing I'm going to talk to you about is Redux.net. So where NGRX is an implementation of Redux on top of Rxjs, Redux.net is an implementation of Redux on top of the C# Reactive extensions. So this is the thing that gives you the objects like the store, reducers, effects, that kind of thing. So yes, comparing NGRX to Redux.net, they both have a store, they both have observable concepts, and the state changes are observable. They both have reducers. NGRX has the concept of side effects. Redux.net didn't have effects, but it's got this thing called middleware, but then I used that to make my own kind of effects library on top. So that's what I'll be showing you today. So let's move on to my demo. When I build a demo these days, there's one place I always start, and that's Jason Taylor, because he made this little thing called Northwind database. It's a Northwind database setup for Entity Framework core, and you just go and get it. You've then got the Northwind database in your Hello World application, and you can start doing some stuff with it. In my case, my favorite database is Postgres, so I took this Northwind Entity Framework thing and dropped it onto Postgres on top of Linux. So let's do a little basic test here, and hopefully I can get through this first half of the demonstration without falling into a coma, because it's really quite simple. I hit the customers list, there's a list of companies, customers, yay. I can hit the edit, I can edit it, I can make a change. Let's change that city. It detects that I made a change, and that gives me a Save Changes button. I hit make a change to the city, hit save. That's great, it's saved. I go back to the list. Yep, that city was changed. Great. Nothing that spectacular there. But let's see what happens when I create a second browser and take a look at the same thing. Really a bit temperamental. Okay, I hit edit here, and I hit edit there. And now I start making some changes in here, and straight away, those changes are synced between those two browsers. This isn't just browsers on the same machine, this would be any two browsers watching this same web application. I can make a change. Yep, that's changed across places. I can actually click Save Changes over here, and the fact that I've saved comes across and removes the Save button from the other side as well. The other thing you can do here is if I come back to the customers list, and I'll do the same here. I hit edit, I'll make a change. You can see my changes on the thing I'm operating, I've got open, isn't immediately flowing to the grid. But if I hit Save Changes now, then that comes across. So that's the demo. So let's take a look at some of that code and how we got there. And this is the GitHub. Everything you've just seen that makes that work is available on GitHub under this URL. I'll bring this slide up later. It's .NET 2.1 preview. I've not updated it yet, but you know, I thought I'd make the slides work. So let's take a walkthrough of this code. Because what we've actually got is we've got a client-side ASP.NET single page application built with Angular. And that itself is using its own Redux pattern. So that's pretty standard, having a Redux pattern on your JavaScript side. But then on the server side, I've got another Redux pattern, keeping track of the state between the two systems. Then I've got SignalR in the middle, joining them together. So let's take a look and start with the store, where we're storing our data. So we've now got, this is where we're storing our shared state that's shared between all the clients that are connecting to our system. And our state looks pretty simple. We've got a global customer list, which is a list of all the customers in my system. I've then got a list of open customers, and for each open customer, that's got a reference to the customer, a reference to the users that have opened that customer, and then a Boolean is changed. And that's what's driving the Save Changes button on the edit screen. So if it's changed, the Save button comes up. As soon as I've cleared if's changed, that gets wiped out. So it's pretty simple. So this state, I take it and put it inside the Redux.net store. So here we have the single customer store. It contains a reference to that customer state. The next thing I'm going to show you is how actions get applied on that store. And I'm going to start with the most simplest action areas, which is that initial load customers. And I do something slightly differently here. I decided just to show that it's possible, is when the application starts up in startup.cs, at that point I'm just going to take all those customers and put them into memory. You don't have to do that, but I thought this makes a good demo. So at the end of startup.cs, you can see I'm setting up Swagger UI, setting up the sparse stuff. This is just basic ASP.NET Core startup application, but I'm newing up a customer manager, and then inside the customer store, I'm dispatching an action, dispatch load customer list action. So let's take a look at how that runs. This pretty much follows that whole stride we had earlier of how an action flows through the Redux pattern. So we've fired a load customer list action. That's going to call an effect that's going to talk to the database, but that effect can't update our store. So when it's successful, it then raises another action, load customer list complete, and that finally goes through a reducer and will put that list of customers in the store. So load customer list action, this is an action with absolutely no parameters. It's just do this thing. So away it goes. And let's take a look at the effect. The effect itself is pretty simple. Because it's an effect, remember effects can take in services. So in this case, the service we're giving it is that Northwind DB context. So we've taken the DB context and we use that to load customers. And then once we've finished loading the customers, we're firing this new action, load customer list complete. In this case, we've got an action with a parameter. The parameter this action is taken is our list of customers. So here it is, load customer list complete. We've now finished our work with the database. We have a list of customers. We're raising this new action. So this action then goes through to a reducer, which is our load customer list complete reducer. And all this does, remember, reducers are pure functions. Reducers take in our previous state and they take in an action. And in our case, the action it's got is the action that contains the list of customers we've loaded. So all we do is then, all right, let's set that inside our state, and we're done. So that's one loop through of do something, load something, change our state, modify it in the store. So let's take a look at how we can actually use that now. How are we going to get that state from the store across the wire via SignalR to our client application? And to do that, we're going to start by looking at SignalR. So SignalR actually has two libraries to make it work. One that lives in JavaScript on the client side, and one that lives on the server side. So, on the client side, we have this library we've pulled in, ASP.NET/SignalR. And that gives us an object called Hub Connection. And that's the thing we're going to use to manage all our persistent connections between our client and our server. Then on the server side, we have this thing also called a hub. And on the server side, the hub completely replaces what we'd normally use a controller class for. So if we're doing normal request response operations using MVC in ASP.NET Core MVC, we'd have a controller, and that controller would sit there, wait for requests, respond to requests, and send back responses. Instead of the controller, we've got the hub. But I think when working with hubs, the way to think about it is it's like a controller. You want to keep the logic out of the hub because the job of the hub is to communicate with the client. Just in the same way the job of a controller is to just take in your request, get it into a format that's ready to be used, and pass it through to the application there that contains your business logic. So let's now walk through a instance of sending a message or sending a request from the client up to the server. So I'm inside the client, I'm calling this.hubconnection.invoke, and I'm saying customer list subscribe. So that name is an arbitrary name I've given it. I could have called it anything I like, but I've decided to call customer list subscribe. And then that invokes a task on the server side with the same name, customer list subscribe. In this case, it's just I want to get the list of customers. There's no parameters involved. So what then happens is we go to the store container customer store, and we select. And when we select, remember our state's got quite a few things in it. It's got the customer list. It's also got the list of open customers. But the thing we're interested in is that customer list. So we go select state.customerList. What we get out of that select object is an observable. So we now have an observable on the client side that's just like the observables we've seen in Rxjs on the server side, on the client side. So because it's an observable, we can do all kinds of things with it. We can merge it with other observables. We can call where. We can call, in this case, what we're doing is we're calling distinct until unchanged. So we're going to only emit when this value is changing through the system. And then we're going to subscribe. And this bit is quite interesting to me as well, because this chunk of code here feels like and acts like a JavaScript callback or a promise. Because what happens here is we're setting up this function to run later when that observable gives us a value. So we are no longer having a request response cycle where I say, give me this thing, I'm going to wait for the response, here's the thing. We're going to say, I'm subscribing to this thing, and I'm going to exit. At some point in the future, this block is going to wake up because there's a new value on that observable. And it's going to fire and basically raise, hey, I've got a new customer list for you. So what then happens is this little block inside these brackets here, this is no longer part of the same request, the same function as this customer list subscribe. It's a callback. It's happening later, just like in JavaScript. So what this then does is has to get access back to the hub context stuff, which is all the SignalR stuff we need to get our connection. And we're sending a new function, push customer list. So the key thing here is we fire one function up, customer list subscribe. We set up the listener, and then in the future, it will call customer list push and push that list of customers back to the client. But the key thing here isn't just do this once. From now on until they unsubscribe, every single time that list of customers changes, it's going to push that back to the client. So it's a fire once, listen, and stay listening type of response. So that's the kind of the simplest one, the global get customers list. I'm going to show you that again, this time for opening a single customer to work on, because this then has some more parameters involved. So when I open a customer, I'm actually going to pass through an ID of the customer I want to open and take a look at. But pretty much the same thing happens there. I get the open customer come in, and the first thing I do is set up my subscription. What am I going to do to receive events and future events for that customer? And then I dispatch an action. So in the previous one we saw, it was get customer list. Well, I already knew the customer list had been loaded. I started to do it really early on and just load it first thing, so I always know there's some customers there to get. In this case, the list of open customers is every time someone looks at a customer to open it, we'll put that state in the store. So if 3 people go to the same customer, they'll all have the same customer. But if you just by yourself go and look for a customer, that's not sitting in memory until I've asked for it. So I call the open customer and I pass through the customer ID I'm looking for. Then later on, after that open customer is loaded, so now I'm disconnected. The actual stuff that's happening in the store is happening after that dispatch. But at some point in the future, there will be a customer in the state for me. And that's when this callback will happen and sends that customer back through to the client. So I've broken up the request response to request coming in, set up a listener, exit. At some point in the future, another asynchronous action comes back and gives me the value. And that finally pushes it back through to the client. So the final one I'm going to show you is the save customer operation. And I find this is important because one of the key features of using the Redux pattern is making side effects explicit. If something has a consequence somewhere else, I want that explicitly listed in the code, not just happening in the background. So let me show you what I mean. And if you remember our demonstration, when we hit save customer on one screen, if I had the list of customers open, that would get updated. So the consequences of hitting save on a customer is the customer gets saved and we know that the full list of customers out of date needs to be updated. So let's take a look at how that flows through. So we fire the save customer action, and we're going to then be fed the action, the customer to be saved. We're then going to use the effect to save that to the database, and we're going to feed that the customer successful action. Now, because we've saved the customer, we know we have two things need to happen. One is we update the reducer, so the store knows that the customer is saved, and we can then trigger a new action, which is, okay, the list of customers out of date, let's trigger that load. So the idea is we've made those side effects completely explicit. So let's take a look at that. So we start with the save customer action. This is just an action, again, fairly small. All it says is, to perform this action, you need to feed it the customer. Great. We then call this thing called save customer effect, and the save customer effect writes to the database. Pretty standard DB context entity framework code here. Then when that's finished, we call the save customer successful action. Again, this is a very simple action, just passes a customer reference along. And the first thing we do is the reducer. Well, in this case, we just say, okay, we're going to update it. And the key thing we set that is changed to false. So the customer in state has changed. And the fact that it's changed is false, now on both people watching that screen, that save customer button will disappear. Then we have this side effect. And this side effect, even though it sounds complicated, is incredibly simple because all it does is it picks up the save customer successful action and says, oh, all right, if this happens, I also want to load customer list. So it's this tiny piece of code that's setting up the fact that I make a change, I'm hitting this save button, something else needs to happen. Now I can add as many side effects like this as I want to and reference either write code inside that effect or just reference other actions to run when they do it. Because after every effect, just feed it an action and that feeds through. So then finally, that comes through and it loads customer list action. Well, while I'm messing with this, has anybody got any questions? So here we go, that's now changed. That's a very good point. The question there was, how well does it work once you've got a load balanced service? And I'll actually come to that point in a minute because it is something you have to consider. Because the thing to remember is what we've now set up is a state service and not a REST service. Let me come to that. I haven't got some time. So what I was going to show you is when I'm setting up these subscriptions, I've actually created a service in the background that's keeping track of all the subscriptions I've made against the client that connected them. So with SignalR, there's a client connection reference, so that when that client later on disconnects for whatever reason, I can go, oh, right, that one's disconnected. Let's go and destroy all the subscriptions. I'm not having this memory leak of all these subscriptions hanging around on the server. So the question was about dependency injection. How do you handle that? And well, yes, you can dependency inject into the hub the same way as you dependency inject into your controller. But my recommendation is you try and avoid putting logic in the hub that you don't have to. I put that into that whole Redux loop. So dependency inject into your effects because they can have the injection, and you don't dependency inject into reducer because you can't. So there's a clear separation from the functions that can do dependency injection and the functions that can't. So in conclusion, generally I don't care what programming language you use. What's far more important is what design pattern you're using. What's the ideas that are making the data flow through your application? And things to consider are readability and predictability. Is it going to do the same thing every time, guaranteed for sure? Not, I've made this change, but I don't know if it's going to work this time. This comes back to the point that was just raised. This solution is not REST. So the way we've been going recently with all web applications is everything is REST, and that stands for representational state transfer. The idea is your web servers don't have any concept of permanent state, so that when you're dealing with a farm of servers, you can send it to any of those servers and it'll always give the same results. But that means all the state is being stored on that web server. But that might not always be what you want. I don't think every single solution fits that pattern. And certainly this solution, where we've got this screen sharing and this state that's being shared between two clients very immediately, that needs to have state somewhere. And that state can't just be on the client. So this really comes down to REST is obviously very easy to scale up. But if we have to have state on the server, thinking of ways to manage that. And obviously microservices is a good solution where you have certain microservices that look after a certain part of the state. So say this is a state service, this is a stateless service. As long as you're clear and understand that this is a stateful service, so you have to be routed to the same point, Another thing around that actually is when you're dealing with SignalR, it's a permanent connection between the client and the server. So the next request won't get bounced out to a random server in the pool. You have a maintained, kept open connection. So as long as the two systems are going to have that shared state between them, that will work. But obviously, if you're going to a farmer service, you need some kind of state service that's not just in memory. You need to have some kind of cache to keep that sort of state. But you could put a Redis cache database in the background, but then have the Redux listeners listen to the Redis cache instead of loading straight from the database in order to have that shared state between systems. So the other thing we saw SignalR. So SignalR allows full bi-directional communication between the browser and server, which is great. But it does replace this client-server pattern that we've had for as long as I've been web developing with asynchronous events. And asynchronous events are harder to manage. You have to start thinking about asynchronous events. So Rx is a pattern for managing asynchronous events with observables, subscriptions, and operators. And Rx is available for pretty much most languages. And it's mostly used for UI frameworks, but I see no reason why you can't apply it in more places it's being used right now. And finally, the Redux pattern builds on Rx to provide a state management framework. So the Redux pattern is what gives you things like the store, selecting from the store, actions, effects, and reducers. And the idea of Redux is it's constrained to constrain state changes and avoid mutable soup. And one of my favorite features of that is those explicit side effects. If something has a side effect, it's explicitly put in an effect. You can't be clearer than that. A couple more things to mention. Another reason I was very excited to look into Redux.net is Blazor. If you don't know what Blazor is, it's a WebAssembly library that will take C# code, compile it to WebAssembly, and run C# on the browser. It's amazing. But I'm thinking, if I'm going to be using this, I don't want to lose all the amazing stuff I've just learned with Rxjs and those Redux patterns. So you can. And someone has already made Blazor Redux. So this takes that Redux library we've just used and puts it in Blazor. So if we do all decide to move to Blazor, which I hope we do, then we'll still be able to have Redux. The other honorable mention, of course, comes to Firebase, because Firebase does give us this ability to have this database that gives us observables on the client side. But now with this, you don't need to use Firebase to have that same real-time experience. You can roll it yourself. So in conclusion, you can bring SignalR, Rx, and this Redux libraries together to apply those patterns across the full stack of the web application. Another thing I want to bring clear about is you can build quite a complex system where every individual component is actually quite simple. So each of the classes you've seen are small that do one or two things in a very clear and tightly constrained way. So you can build some complexity out of many small, simple, self-contained operations. Yeah, any more questions? We've got 5 more minutes. Yes, it is on GitHub, that demo, yes. Yeah, so the question was, is the Redux pattern tied to the domain? It's not really. What it is it's outside of your domain, because obviously the store is your domain. The shape of the items in your store, that is your domain. But what the Redux pattern is a very constrained way of making those mutations to your domain. So rather than just going to the object that you're storing in your domain and changing it or just writing to the database, you've got this very constrained pattern. But yeah, obviously all the logic that you put in to your DDD can easily be applied within your reducers, yeah. Yes. That's right, yeah. So yeah, I was just saying, in DDD you have domain events, and I'm pretty sure you can remodel domain events to actually act as Redux events if that's what you wanted to do. Yeah, the other comment was it's similar to CQoS. Yes, I mean, all these things constrain your application in some way. You say, we're always going to do it this way, always going to do it that way. And yeah, CQoS and Redux can work together as well. You can have actions that are, I mean, Redux is like CQoS in the fact that you select from the store are your reads, and your actions are your writes. Yeah, so the question was, do I need Redux if I'm already using domain events? And potentially not, no. I mean, they're two patterns to do a very similar thing, but I think if you have a huge amount of asynchronous events, like inside a user interface, then maybe Redux is the better pattern. But if you've got a very well-made DDD model, then maybe not. Those domain events would be great. But you know, they're all different tools that might fit your model in different ways. So there's the link of all the demo code we've just seen. So there's quite a bit in there that I haven't covered. There's some bits that Redux.net itself doesn't have the concept of effects, but I added my own stuff into their middleware. And also there's more stuff around subscription management. Plus there's the whole client side I didn't show you. On the client side, I'm using a Redux library called Rxjs just to try it out. So that's all in there as well. But it's kind of a demo to see what can be done. I haven't thought through all the ramifications or load tested and that kind of stuff yet. It's kind of fairly early days with this thing. But certainly if you're looking to push this out to a massive farm of servers, you're dealing with a state service rather than dealing with a completely stateless REST service. So that's definitely worth considering. But if your model is small enough, and in so many cases I'm seeing people worrying about performance when their model is so small and fits in memory, then why don't you just put it in memory and deal with the writes to database later, because databases are slow and memory's fast. Well, the question there is if you move to Redux and you change the new user base and new user interface, I mean, that really is how you define that API. And in this case, your API is actually those events you've set up on SignalR. If that's still well-defined and well-separated out, then you don't have to rewrite your clients as long as you've got a client that supports SignalR and then deals with those events in a sensible way. I've had a quick play with Blazor and I love it. I think JavaScript should die. Yeah. So, was the mic still on?
Yes.
Yes, great question. So the question there was, using C#, did I find it harder than JavaScript would be to create reducers because you've got this system like immutability, and in JavaScript it's very easy to use a spread operator to make these operations. And yes, it would be, it is quite a little bit harder to make that in C#. And one fundamental consideration I was seriously thinking of is making that little bit of the code in F#, because F#'s got those functional things where you can make, so I'll probably, if I was to do this for real, I'd make that little bit that was handling the reducers in F#. And then you got that sort of much nicer APIs for dealing with things in that functional way. It's a great question. So thank you for listening and staying to the end.